As I mentioned at the end of the last video, we're going to head into a detailed discussion, not just of VPN operation, but we're going to show you how the certificate authority fits in all this. I want you to see an illustrated look at how keys and digital signatures move around. So I've got a new application that's going to help us do that. We're going to use that in the next video. Right here, we're going to do a little more text here with RSA and one other situation I want to show you from Wikipedia as well. So let's dive in here, because with RSA, this time the name isn't the recipe, it's a name. Or actually, it's initials. It's the three people, RSA, who actually developed RSA. Now, as Wikipedia notes, it's widely used in electronic commerce protocols and is believed to be secure. Here come the disclaimers. Given sufficiently long keys and the use of up-to-date implementations. Both of those, of course, great ideas. The longer the keys, the more secure we are. Now, a couple of RSA fun facts here. It's the first encryption to be considered suitable for digital signatures. And we're going to learn all about digital signatures in the very next video. You probably have an idea of what those are to begin with, but we're really going to get into the detail on them. Another thing we have to get used to that we'll see in the next video as well is that we're going to be using with RSA, there's a key pair. We've got a public key and a private key. The public key everybody can see, the private key only you can see, or only the device that has that key can see. Now, of course, slow operation, a very relative term in networking. The network is slow today, but slow operation with RSA in comparison to a symmetric algorithm. But RSA has been around since 1977, and there aren't many things from 1977 that we're still using in today's networks. Now, DiffieHellman, it makes secure key exchange over a non-secure channel possible. And if you saw that line for the first time, say, on a certification exam, you'd say, well, that can't be right. How does that work? Well, DiffieHellman actually does make that possible. Now, here at the CCNA security level, we're not going to get into every little detail of how DiffieHellman makes this possible. Again, Wikipedia's got a great page. There are other sources out there if you want to do reading beyond that level. I think that's great, but we're not going to get into every detail here. What I do want you to know is that the endpoints are going to agree on a non-secure, non-secret numeric value before DiffieHellman can get to work. I mention this because if you do that extra reading, note that these are not keys. These are non-secret numbers. Now, another thing you might run into occasionally is you see it called DiffieHellman Merkle. And the reason I mention that here is I don't want you to see that in another book or, on Wikipedia or on the web somewhere and say, well, who's Merkle? Is this the same thing as DiffieHellman? Do they do the same thing? They do the same thing. There's a bit of a long story about why Merkle was dropped off, but there is a movement to express it as DiffieHellman Merkle. So if you see it expressed that way, it's the same thing as DiffieHellman. Now, DH does not include authentication, though, and it's therefore open to man-in-the-middle attacks, any kind of attack there between point A and point B. Now, speaking of things that have been around for a while in networking, let's talk about DES for a moment. DES was originally developed in 1976, and again, things in computing have changed just a little bit since then. The big issue with DES is that key size that I mentioned a moment ago, because it's 56 bits. And if that sounds like next to nothing, you're right. Now, that was fine 35 to 40 years ago, but again, things have changed. And depending on whose article you're reading or which book you're reading, you can read the DES can be broken in just a few minutes to a few hours. The key thing is it can be broken. The block ciphers that are used by DES are part of that problem. And the first one, Electronic Codebook, ECB, it's just not very secure. And the problem, as I'll show you here from Wikipedia, this is ECB. If you want to see these, let me go back to the webpage here. I've got it right there where I didn't want, yeah. There's the larger drawing, and I will show you the page this is on as well. But you can see what's going on. We call this block cipher encryption. And what we're doing is taking a fixed block of text, and we're turning it into, or translating it into, if you will, a block of ciphertext. So it looks like a bit of a pattern there, doesn't it? We're not too much on patterns. Let me show you the name of this page. It's Block Cipher Modes of Operation, if you want to check this out. And again, the block cipher, what we're doing now, it's using one key too. But let's go down to that drawing again. this is what ECB looks like. And then you've got the decryption. Of course, that's just going the other way. We're taking the block of ciphertext, applying a key, and here's your plain text. And as Wikipedia mentions, the disadvantage of this method is that identical plain text blocks are going to be encrypted into identical ciphertext blocks. It simply doesn't hide data patterns well at all. In some senses, it doesn't provide serious message confidentiality, I would say in all senses, and it's not recommended for use in cryptographic protocols at all. So when you see something like that and you know that's part of DES, it's like, maybe we don't want to use that. This is an excellent example. You could look at this encrypted using ECB mode, and I'm pretty sure you could tell me what that is or give me a really good description of it. So that is not something we want to use in today's networking. And again, that problem is that each 64-bit plain text block is going to be encrypted by the same 56-bit key. Now, there is something else called cipher blockchaining. And CBC, that problem doesn't exist because every plain text block has what we call an exclusive OR, XOR operation run against it with the previous ciphertext block before it's encrypted. So that's a pretty good deal. But again, DES, you're not going to run into that too often. So you might think, well, why are you even mentioning it? Well, something you might run into is triple DES. It's just what it sounds like. The DES encryption procedure is run 3 times with 3 different 56-bit DES keys. The effective security is considered to only be 112 bits, though. Another way you might see this expressed in documentation is TDES or 3DES. So again, if you see it any one of those 3 ways, you know they're talking about triple DES. Now, here's one that you won't be breaking anytime soon. It's the Advanced Encryption Standard. I mentioned it's being rapidly adopted by organizations and governments worldwide. That's actually a bit of an understatement. A lot of them, those organizations and governments are already using them. You can use AES on any Cisco router that has IPsec DES TDS capability. You do not have to know how AES works for the CCNA security exam. That's about all the detail we're going to go into it on right there. But please, again, feel free to check it out on Wikipedia. And there are other good sources out there. Wikipedia is not paying me to mention them so often in this section. But what I have found is, especially for people who are totally new to this, seeing those illustrations that they've been kind enough to post up there really does help. Now, speaking of illustrations, what we're going to do now is head into a discussion of the PKI fundamentals, public key infrastructure, but I'm not going to use this particular whiteboard or use OneNote. I've got a new application up that I'm going to bring an illustrated look up so we can see at the entire process. So we can see how the keys move around. We can see when this thing called a certificate authority gets involved. It's much better than learning it in text, because when you've got all these keys going around and signatures and encryptions and everything else, illustrations really help. So I'm going to bring that up at the beginning of the next video. We'll go through that, and then we will take a look at IPsec illustrated version right after that. So I'll see you on the next video.